let's go ahead and talk about diluted earnings per share. Diluted earnings per share, what we're trying to do is find the worst case value for earnings per share. In other words, we know basic earnings per share. How low could earnings per share have gone if all of the dilutive securities had been exercised or converted? Again, dilutive securities are those which will result in the issuance of additional shares of common stock. You issue more shares of common stock, that waters down or dilutes the earnings per share. Let's go ahead and start with a coin example. Let's imagine that you've got 1 quarter, 1 dime, 3 nickels, and 3 pennies. And assume that the quarter is your basic earnings per share. So you have 25 cents for 1 coin. We want to find that combination of coins, including the quarter, that has the lowest average value. Now, if we simply added all the coins, we'd have 53 cents divided by 8 coins is 6.625 cents per coin. Is that the lowest average? Now, looking at those individually, we say, well, if you add the dime, that'll bring the average down. If you add the nickels, that'll bring the average down. And if you add the pennies, that'll bring the average down. But will adding all of them give us the lowest average value per coin? The answer is no. The process we're going to follow is a simple, relatively simple, 3-step process. Step 1, we're going to rank the coins from smallest to largest in value. Then we're going to take the first coins on our list, in this case it'll be the pennies, and put them into the mix and say, okay, with the quarters and the pennies, what's the average value per coin? After getting that new average, we'll look at the next coin on the list, the nickels. And again, we'll ask ourselves, if we add the nickels in, will that bring the average down or bring the average up? And we'll continue this process until we get to the lowest possible average. So let's go ahead and see how this works. Remember, we have our 1 quarter, that's our basic earnings per share, 25 cents per coin. We have 1 dime, 3 nickels, and 3 pennies. First, we're going to rank them from smallest to largest. Number 1 is our 3 pennies. Number 2 is our 3 nickels. Again, the pennies are 1 cent per coin, the nickels are 5 cents per coin. And number 3 is the dime, 10 cents per coin. So we start with our basic earnings per share. 25 cents for over 1 coin is 25 cents per coin. We look at the pennies and we say, okay, the pennies are a penny per coin, so we're going to throw those into the average, and they should bring the average down from 25 cents down to some smaller number. So with the pennies, we've got 25 cents for the quarter, plus 3 cents for the 3 pennies. 28 cents divided over 4 coins, our new average is 7 cents per coin. Now we look at our next list, the nickels. And we say, okay, the nickels have an average of 5 cents per coin. Our current average is 7 cents per coin. So if we throw the nickels into the mix, that'll bring the average down a little bit further. So we have our initial quarter. We're going to have the pennies in there because they brought the average down. And now we're going to add the 3 nickels at 15 cents. So now we've got a total of 25 cents plus 3 cents plus 15 cents, or 43 cents, divided over 7 coins, 1 quarter, 3 pennies, and 3 nickels, for an average of 6.14 cents per coin. Now we look at the dime. The dime has an average of 10 cents per coin. Clearly, if our current average is 6.14 cents per coin, if we throw a dime into the mix, it's going to bring the average up a little bit. So we're going to go ahead and stop right there and say that our diluted earnings per share, our lowest value per coin, is 6.14 cents. And just to illustrate that we need to stop there, if we just kept on going and threw the dime in as well, our average would rise to 53 cents over 8 coins. Again, the quarter, the 3 pennies, the 3 nickels, and the dime, 53 cents over 8 coins, or 6.625 cents per coin. Again, our job is to find the lowest average, and the lowest average is 6.14 cents per coin. So what does all this have to do with earnings per share? Basically, we're going to follow the exact same procedure. For each potentially dilutive security, whether convertible bonds or convertible preferred stock or options or warrants, we're going to compute what's called the per share effect. That would be analogous to the value per coin in the coin analogy. The per share effect is the increase in the earnings per share numerator divided by the increase in the earnings per share denominator, assuming that the potentially dilutive security was converted or exercised at the earliest possible date during the year. Again, earnings per share is income minus preferred dividends divided by weighted average shares outstanding. For a convertible bond, the per share effect would be the after-tax interest avoided in the numerator, that would be the effect on the numerator of earnings per share, divided by the incremental shares issued, that would be the denominator of earnings per share. For convertible preferred stock, it would be the preferred dividends avoided in the numerator divided by the incremental shares issued in the denominator. Let's go ahead and start. Let's do an example, but let's take the per share effects as a given. Computing the per share effects is, in my view, the hard part of this problem. Let's go ahead and start and assume those effects are given. Let's assume we have basic earnings per share of $1 million minus 100,000 in preferred dividends divided by 900,000 shares equals $1 per share. And let's assume we've got the following potentially dilutive securities with the indicated per share effects. Let's have some convertible bonds with a per share effect of $200,000 divided by 250,000 shares, or 80 cents per share. We've got some convertible preferred stock with a per share effect of $100,000 divided by 200,000 shares, or 50 cents per share. And we've got some options with a per share effect of $0 divided by 400,000 shares, or 0 per share. And again, we'll talk about how those numbers are computed after we do this example. And again, step one is to rank these from smallest to largest. Number one would be the options, because their per share effect is 0. Number two would be the convertible preferred stock, because its per share effect is 50 cents per share. And then lastly, we'd have our convertible bonds at 80 cents per share.
Okay, so here is our basic earnings per share and our ranked per share effects. Now we're going to start with number one, the options. The options have a per share effect of 0, so averaging those shares in with the basic earnings per share of $1 is going to bring the average down to somewhere between $1 and 0. Now looking at the magnitude of these numbers, our basic earnings per share of $1 per share is based on 900,000 shares. Our per share effect for the options of 0 is based on 400,000 shares. So basically we're going to be adding just under 50% additional shares. So that's going to bring the average down a good bit. Basically it should bring the average down by about a third. So we go ahead and do the calculation. We're going to simply add the numerator and the denominator of that per share effect to basic earnings per share. So with the options, the numerator now is 1 million minus 100,000, our original numerator, plus 0, divided by, in the denominator, 900,000, our original shares, plus the 400,000 shares brought in by the options. So $900,000 divided by 1.3 million shares is 69 cents per share. We then look at number 2 on our ranked list, the convertible preferred stock. It has a per share effect of 50 cents. Since our current earnings per share figure is 0.69, averaging in the shares from the convertible preferred at 50 cents will bring the average down a little bit more to somewhere between the current figure of 69 cents and the per share effect figure for the convertible preferred of 50 cents. Again, looking at the number of shares. Currently, the revised earnings per share of 69 cents per share is based on 1.3 million shares. We're only going to be bringing in an additional 200,000 shares, so in terms of the magnitude of the dilution, it's not going to be that great, but it is going to have some effect in bringing the earnings per share down. So again, we're going to add the numerator and the denominator of the per share effect to the current earnings per share. So again, here's our background information. With the options, it was 69 cents a share. Now we add in the preferred stock, and again we simply add the numerator of 100,000 and the denominator of 200,000 to the existing earnings per share calculation, and we get 0.667. Okay, now we look at number 3 on our list, the convertible bonds. Those have a per share effect of 80 cents. If we add those in, they will bring the average up, so we stop at 0.625. The convertible bonds are anti-dilutive. If you wanted to, you could go ahead and confirm for yourself that adding the bonds in would be anti-dilutive. Let's go ahead and do that. I'm not going to put this in the screen, but just off to my calculator off to the side. Our current numerator is 1 million minus 100,000 plus 100,000, or $1 million. we're considering adding in the numerator of the convertible bonds at $200,000. So the new numerator would be $1.2 million. In the denominator, we currently have 1.5 million shares, and we're contemplating adding in another 250,000 shares to that. So the denominator would rise to 1,750,000. So $1.2 million in the numerator divided by 1,750,000 in the denominator would give us a figure of 0.686. So it would bring our earnings per share up a little bit, not a whole lot, but it would bring it up a little bit. So again, we're going to stop at 0.667 or 0.67. That is our diluted earnings per share.
Now let's go ahead and talk about how we compute those per share effects. Again, the per share effect is the change in the numerator and the change in the denominator of earnings per share, assuming the potentially dilutive security was converted or exercised at the earliest possible date during the year. Let's go ahead and start with an example of convertible bonds. Let's assume we've got ABC Company has $1 million of 10% 10-year convertible bonds outstanding that were issued a few years ago at 98, and ABC uses straight-line amortization. Each $1,000 bond is convertible into 50 shares of common stock, and ABC faces a 40% tax rate. So again, what we're going to want to have is the interest avoided in the numerator, the effect on the numerator, divided by the additional shares being issued. Now, as far as the interest avoided is concerned, the coupon or cash interest is 10% of $1 million or $100,000, plus or minus any amortization. These bonds were issued at a 2% or $20,000 discount. Straight line over 10 years, that'll be $2,000 per year. And we know that discounts increase our interest expense. And we're going to take that total, the coupon interest plus or minus the amortization, and we say, well, if we avoid $100,000 in interest, our income will go up by $100,000. The government's going to take 40% of that, leaving us with the other 60%. So we multiply that by 1 minus the tax rate. So that's the effect on the numerator. And then in the denominator, we put the additional shares that would have been issued had these bonds been converted. So in this case, $100,000 of cash interest plus $2,000 of amortization is $102,000 times 1 minus the tax rate divided by the number of shares. Again, there are 1,000 bonds. Each of those $1,000 bonds turns into 50 shares of stock, so 50,000 shares. So the per share effect is $1.17.6. For convertible preferred, that's going to be a little bit easier because A, we don't have to worry about amortizing discounts or premiums, and B, there's no after-tax aspect because dividends aren't a tax-deductible expense. So let's go ahead and assume that ABC Company has 20,000 shares of $100 par, 6% cumulative convertible preferred. And I've made it cumulative because that way the dividends would have been deducted in computing earnings per share. The dividends would have been deducted whether declared or not, so we don't have to worry about whether they were declared or not. Each share of preferred is convertible into 10 shares of common. So again, what we want to do is look at the dividends that would be avoided divided by the additional shares that would have been issued had these shares been converted at the earliest possible date during the year. So the dividends, $100 par, 6%, that would be $6 per share, times 20,000 shares is $120,000. In the denominator, 20,000 shares of preferred, each being converted into 10 shares of stock would be 200,000 shares, so the per share effect, $120,000 divided by 200,000 shares, is 60 cents per share. Finally, options and warrants. For options and warrants, we're going to use what's referred to as the treasury stock method. Now, options won't be exercised. We won't assume exercise unless the exercise price is less than the average stock price during the year. If your stock price is $50 and the exercise price is $75, then clearly nobody would exercise the options. So we insist that before we include options or warrants, the exercise price has to be less than the average stock price during the year. And what we're going to do is we're going to assume that the shares that are under option are issued. We're going to take the proceeds and buy back treasury stock on the open market at whatever the average stock price is during the year. And so the number of shares issued minus the number of shares repurchased will be the incremental shares outstanding in the denominator. The numerator is always zero because issuing stock and repurchasing stock never has an effect on our income. So the per share effect for options and warrants is always 0, but you need to know the denominator, how many shares are going to be issued. So let's go ahead and assume that we've got 1,000,000 stock options outstanding. The exercise price is $10. The average stock price is $25. So we're going to go ahead and assume we're going to issue 1,000,000 shares for $10 each, or $10 million. We're going to turn around and take our $10 million and buy back treasury stock at the average price of $25 per share. So how many shares can we buy back with $10 million if they cost $25 each? We can buy back 400,000 shares. So the per share effect, the incremental shares, we issue 1,000,000, we buy back 400,000, so there's a net increase of 600,000 shares. So the per share effect is going to be $0 divided by 600,000 shares, or $0 per share. Again, the numerator of the per share effect for options and warrants is always 0, because issuing or buying back your own stock never has an effect on your income.